Hey guys, my name is Matali, and in this video I will be teaching how to convert dash wedge structures to Newman and Fisher projections. So we're going to start off by looking at this molecule I've drawn out right here. Take a moment to pause the video and review your naming. Okay, so we'll do this together now. When naming, we want to identify the longest carbon chain. So over here that'll be a 4-carbon chain, which corresponds with the ending butane. And we see that on the second carbon, there is a chlorine attached. So that's 2-chlorobutene. Okay, so now it's important to understand the structure we're looking at drawn out here. So with this dash wedge structure, we see that these are the 2 central carbons that I just drew in red. And these 2 central carbons are each attached to 4 different atoms, meaning that they are sp3 hybridized. And anything that's sp3 hybridized is 3D in nature. So that means we'll have things pointing towards and away from us. So the atoms that I am drawing in the red are the wedged atoms, and these are pointing towards us. So wedge equals towards us. And then the dash, which corresponds to these 2 hydrogens in the back, point away from us. So now I have a video that I'll show explaining this a little more clearly so you can see it as a 3D structure with a ball and stick model. Hey guys, so this is a 3D ball and stick model of the compound I had just drawn out. We're going to pretend that this purple ball is the chlorine atom. You can see that you have your 2 central carbons here, which are both sp3 hybridized since they have 4 things surrounding them. And then you can see that the carbon chain, which is 4 carbons long, is this yellow carbon, the CH3 group, the central carbons, and then another CH3 group. Since this is a 3D molecule, we see that the chlorine and the hydrogen are pointing out towards us, while 2 other hydrogens on carbon 1 and 2 are pointing away from us, which is the red and the blue in the back. When converting this to a Newman projection, it's important to understand that we're just looking at the molecule from a different orientation. Currently, you see that the carbon chain is aligned right here in this zigzag motion, right? So when we're converting it to Newman, we are essentially rotating the entire molecule and looking at it from this kind of an angle. So you can see it's just turning the molecule and redrawing the way it looks, right? And we see that the atoms that were initially pointed out towards us in the 3D configuration now end up on the left side of the Newman projection. So the chlorine is in the back this way, while the hydrogen is here. So now we're going to take a look at how to draw this on paper. Okay guys, so over here I've just attached a picture of what we just saw in the video, so it's easier to refer to while figuring out how to draw this Newman projection. So just to make things a little clear, I'm just going to go ahead and label these pictures. The yellow represents the CH3 along with the green CH3, CH3. And the purple is our chlorine. And then the rest of the atoms are all hydrogens. So now, when converting the molecule, we're going to refer to this Newman 3D we have right here. So we see that we have 2 carbons. However, in the Newman, the back carbon is hidden. If we just look at the front carbon, we'll see it's attached to a CH3 methyl group along with 2 hydrogens. So we're going to draw that down here. There's a CH3, hydrogen, and hydrogen. And the back carbon, which is hidden in this structure, right? It's hidden in this structure, but you can see it right here, the back carbon, is attached to both a chlorine and then to a hydrogen and then a CH3 group down here. So it's attached to a chlorine, a hydrogen, and a CH3 group. So we're going to represent the back carbon with a circle. It's attached to a chlorine, which is on its left, a hydrogen on its right, and then CH3. So I'm just going to go ahead and draw the back carbon again with blue. So our back carbon is going to be attached to chlorine, hydrogen, and then methyl. Chlorine, hydrogen, methyl. So now you can see how in this diagram, the center, which is represented by this line down here, corresponds to this center over here on the 3D ball and stick model. And then you can see how when your molecule is oriented this way, so that the CH3 groups are on opposite ends, whatever was initially on the wedge, like the chlorine and the hydrogen and the purple and orange, end up being on the left side of your Newman. So when the molecule faces like this, the wedge goes to the left of Newman, while the dashes, which are the red and the blue in the back, go on the right of the Newman projection. So now we're going to look at how to turn our Newman projection into a Fisher projection. To do this, we're essentially going to look at the molecule from a top view. So if we just put the Newman projection down like this, we're going to see this two CH3 molecules, this two CH3 groups here, while the chlorine is over here and the rest are hydrogens. So we're looking at it from a top view. So you can kind of see how the methyl groups look like they're on a vertical line on the top and bottom, while the chlorine's on the left, the hydrogen is on the left, and these two hydrogens are on the right. So it's kind of flattening out the molecule this way, and you're looking at it in a 2D perspective, kind of like that. So again, I've just attached a picture of what we were looking at in the video. To label this, we'll say this is the chlorine, the CH3 yellow, CH3 red, and the rest are all hydrogens. So now you can see that this essentially looks like a vertical line with two horizontal lines. The methyl is on the top and the bottom. This represents the carbon we had in the back in our original structure. So this is carbon 1, and this is carbon 2, carbon 2. So carbon 1 had the methyl, a hydrogen, and a chlorine. Carbon 2 had a hydrogen, and a methyl. Carbon 2 had the hydrogen, and methyl. So that's basically all there is to that, and now we'll do a few practice problems. Okay, so here's our practice problem. Say you're asked to convert this molecule into a Newman projection, and they say to draw carbon 4 in the front. So first thing to do is label our carbons. This is going to be carbon 1, 2, 3, 4, 5, and 6. So for carbon 4 to be in the front, that'll be this carbon. Carbon 3 will be in the back. So to make this a Newman, we just want to focus on the carbons. We first just want to focus on the carbons attached to carbon 4. So that'll be this CH3 group. And then we also want to look at this isopropyl group and this hydrogen right here. So I'm just going to draw that out. We have CH3, and since it's on a wedge, it's going to be on the left. The hydrogen, which is on the right. And then the isopropyl group on the bottom. I'm just going to write that as IPR. Now carbon 3 is going to be in the back. I'll draw that in blue, carbon 3. We see that that is attached to an ethyl group, a bromine, which is on its left since it's on a wedge, and the hydrogen, which is on the dash. So we're going to have the ethyl group on the top, bromine on the left, hydrogen on the right. Now, to continue to make this into our Fischer projection, it would be easiest just to look at this Newman structure. So let's just draw a line straight down. This top group, there'll be 2 carbons, right? So this is going to be carbon 3, and then we'll have carbon 4, which is in the front right here. Carbon 4 is our magenta, so carbon 4. On the bottom of carbon 4 is the isopropyl group. On the right is the hydrogen. On the left is the methyl. Then carbon 3 in the blue, we have an ethyl group. So we can just write ET for ethyl. On the right is a hydrogen, and on the left is a bromine. So there we go. We have our dash wedge, Newman, and Fischer projection. I hope that helps.